Okay, in this short lecture, I'm just going to go over the second part of the word worksheet, specifically on implying the empirical rule. I want to make sure that you guys know exactly what you're doing there. Okay, so I'm going to share my screen right here. And we've got this wonderful thing. Um, okay, so we've got this 1.3.3 and 1.3.4. The other lecture covers the first 3 pages. And then this right here, this is more of just practicing on your own. I want you guys to work on that and make sure that you thoroughly understand how to do everything in the practice on your own section. And then let's see here. Dum, 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 dum. Okay, so the empirical rule. I would highly suggest that you keep this sheet around when you are doing your exam. Okay. The reason being is because I have this set up for you to really be able to just demonstrate exactly what it is that that you're dealing with every single time. Okay, and there's a step-by-step process, right? So the very first thing, you find the mean, then you find the standard deviation, and then you do the mean plus the standard deviation. And it literally goes step 2, step 3, step 4, and then step 5 you do the subtraction, and you label all these. And once you label all of these, then you'll be able to really easily determine, okay, how much data is between, or how many observations are between point A and point B. So, for example, in a normally distributed data set, what percentage of the data is more than 3 standard deviations above the mean? And then, so you can look at this. In a normally distributed data set, what percent of the data is more than 3 standard deviations above the mean? So 3 standard deviations, this is 1 standard deviation above, 2 standard deviations above, 3 standard deviations above. So what percent of the data is more than 3 standard deviations above? It's going to be 0.15%. So you notice it says 0.15%. This is the percentage of data that is from this line over. Okay, everything in the blue. This is the percent of the data that is between this line and this line. This is the percent of the data that is between this line and this line, or this is 1 standard deviation above the mean up to 2 standard deviations above the mean. This is 2 standard deviations above the mean up to 3 standard deviations above the mean. And then if I were to say what percentage of the data is within 1 standard deviation of the mean, in other words, plus or minus 1 standard deviation of the mean, it's this is this is the percent of data that's within 1 standard deviation below, and this is the percent of data that's within 1 standard deviation above. So within 1 standard deviation of the mean, in other words, 68% is within 1 standard deviation of the mean, 34 and 34. 95% is within 2 standard deviations of the mean because it includes these 13.5 and 13.5. Now, this green box down here, this is cumulative. So in other words, if you want to know what percentage of the data is below 3 standard deviations below the mean, it's 0.15%. What percent is below 2 standard deviations below the mean? Well, this adds up. This plus this equals this. This plus this plus this equals this. This plus this plus this plus this equals this. So this right here is the cumulative from the left. So just be very aware of that. That's how you interpret the green. So if I were to say what percentage of the data is below 2 standard deviations above the mean, that's going to be 97.5 because you go 2 standard deviations above the mean, 1, 2, and then you go, okay, what percentage of the data? It's this right here because this right here includes all, whoops, all of this right here. It includes all of it. Okay. So let's give this another example. Coming straight up here, let's look at what do we want to do? We can do the very first one. Okay, so age. let's do age, copy this, and I'm going to be a little lazy, and I'm going to go right here, press Control V. Now in this sheet, it says, let's see, he has 15 employees. So this right here is a sample. Okay, so we're going to do equals standard deviation of a sample. So standard deviation of a sample, and I'm just going to highlight all this. 3.577 dot 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 dot. Okay, and then I also need the mean equals average. Okay, and so we've got the average, and then we've got, so we're going to come down here, and we're going to put the average right here. So the average is going to be 21. Okay, and then step 2, so we got 21, and then we've got the standard deviation is going to be 3.5777. Okay, and then we're going to do mean plus the standard deviation. Okay, so we've got the mean plus 1 standard deviation, so that we're going to do equals 21 plus 1 standard deviation. Okay, so it's going to be 24.577. Okay, 24.5777. Okay, and then we're going to do step 3 or step 4. Step 3 equals the mean plus 2 multiplied by the standard deviation, and then we're going to do equals the mean plus 3 multiplied by the standard deviation. Okay, so we've got 24.577, and then we've got 28 point, so we're going to put right here 28.155, and then we're going to do 31.733. And then finally for step 5, we're going to do equals the mean minus 1 standard deviation. Then we're going to do equals the mean minus 2 times the standard deviation. And then we're going to do equals the mean minus 3 times the standard deviation. And so we've got, let's just do this, Control C, Control V, and I'm going to paste the values. So that way I can just go Control C, whoops, Control C, and then 17.422, and then Control C, except that rounds to 5. And then we've got the last but not least, there we go. And so if I were to ask you what percent of the data falls below 21, well, that's easy. That's 50%. Okay. Falls below 21, falls below the value of 21. That's 50% of the data falls below the mean. Conversely, what percentage of the data falls above the mean or above 21, and that is going to also be 50%, because if you got 50% on this side, that means that you have the complement to that, which is 50% on the other side. Okay, now if I were to ask you what percent of the data falls below 24.5777, that's going to be 84%. Okay, but if I were to ask you what percent of the data falls between the values 17.422 and 24.577, well, you're going to do 34 plus 34, which is going to give you 68. 68% of all the data falls between these two values if the data is perfectly normally distributed. So that's how you use this fun little table. And then also it will help you to be able to do all of these as well. Hopefully this will be really good practice for you before you take the exam. I think that it should be. Cool. Thanks, guys.